Okay, well, today I guess this video is going to talk about, again, we're going to continue with talking about exponents, and we're going to talk about continuing section 5.1, multiplying and dividing common bases. And so we did in a previous video, we did these two, reviewing exponential notation and evaluating expressions with exponents. If you need to, you can go back to that. Today's, or I guess this video, is going to talk about multiplying and dividing common bases and then kind of simplifying expressions with exponents. So here's what we're going to do. Application is probably going to come later. We're going to do multiplying and dividing common bases. We're going to do simplifying expressions with exponents, and we're going to remember that we've got information about exponents and bases. If we've got an exponential expression, we've got a base to an exponent n. So b to the nth power is b times b times b n times. So just a quick review, b to the nth power is again b multiplied by itself n times. So right there is kind of the basics information about the chapter. We're going to fast forward because we did that before. Now we're going to talk about multiplying and dividing terms with common bases. Let's take a look at an example. I like to use the example of x squared times x cubed, because 2 and 3 are different. 2 is different from 3. 2 times 3 is going to give us 6. 2 plus 3 is going to give us 5. That's going to be really important to remember, kind of a rule that we have. If we remember our definition of x squared, or our terms, x squared is going to be this, x times x, because remember our base is x. We're going to multiply x times itself 2 times, so x times itself 2 times is that first term. So there's the red terms together, or the red term. X squared is x times x. Now if we take a look at x cubed, I've got x cubed again. X is the base for the green underlined term. X is the base again. We're multiplying it by itself 3 times, so we've got over here x times x times x. So that's our x cubed. So x squared is here in the red, x cubed here in the green, and we've got x squared times x cubed now kind of written in an expanded form. And what we're going to try and do is kind of simplify that. So if we've got x squared times x cubed, what does that give us? It gives us x times x times x times x times x. And if we want to go backwards kind of and rewrite this in terms of an exponent, we'd have a base of x, 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 x. We've got 5 x's, so we're really multiplying that base of x times itself 5 times. So x to the question mark would be x to the 5th power, because we're writing it, so we're kind of taking the long way around to say x squared times x cubed is x times x times x, x, x gives us x. How many are we multiplying together? We're multiplying 5, so x to the 5th power is our answer. And we could see that here's a 5, and here's a 3 and a 2, and how are those related? It looks like we can just add those up. So if we simply add up the exponents when we multiply, then we get our answer. So in other words, if we've got the same base, and we've got exponents, we're multiplying exponents, then it's the base. Our answer is the base to the 2 plus 3 power is the 5th power. So we add, if we multiply terms that have the same base, then we add up the exponents to get the answer. X to the 5th power is x to the 2nd plus 3rd power. Same thing kind of holds true for x to the 5th power divided by x to or x squared power. So if we've got, here's our question, what does that become? X to the 5th power divided by x squared. Well, if we write it out longhand, kind of go the long way around, x to the 5th power again, x is our base, 5 is our power, our exponent. So this means x to the 5th power means we multiply x times x times x times x times x. There's 5 of them up here. And the x squared on the denominator is a base of x, x times x, and it's multiplied by itself 2 times. So we've got x times x. And now this is kind of the long way around. And what we can do is we can know that x divided by x is going to be 1. Another x divided by x is going to be 1. So we can cancel those out. And what we have left is x times x times x. We just rewrite it as x times x times x. And how do we rewrite that? Well, x times x times x is just simply a base multiplied by itself 3 times, so our exponent then is 3. And how are these related? This is the answer is x cubed. How is that third power related to the 5 and 2? 5 minus 2 gives us 3. So let's kind of maybe put this in terms of maybe some definitions. Here's a property that is probably a nice take-home message. So if you're going to leave with some ideas about what went on today, this would be a good one to remember. Multiplication of like bases. If we've got b as a real number, and m and n are positive integers, so kind of like these up here, x is a real number, m and n would be up here, 2 and 3 would be right here. M and n are positive integers, then b to the mth power times b to the nth power is b to the m plus n. So we can rewrite that over here, b to the mth power times, just to make it bigger, b to the nth power equals b to the m plus n, and we showed that up here. So that is right down here. When we multiply these two together to x squared times x cubed, write it out longhand. How many do we have multiplied together? We've got 5 of them. X to the 5th power is 2 to the 2 plus 3 as an exponent, adds up to give us 5 as our exponent. So there's our rule down here. Same thing holds true for division of like bases. We just did division right up in here. What does this say? If b is not equal to 0 and is a real number, and m and n are positive integers, then we've got the rule of b, I'm going to rewrite it over here just for visibility's sake, b to the mth power over b to the nth power equals b to the m minus n. Keep in mind also that all these b's just represent the base of the exponent. All the m's and n's represent just integers. Integers are the counting numbers, 1, 2, 3, things like that. So we've got the bases, we've got bases. As long as the bases are the same, then we can apply this rule. So the bases have to be the same, just like up here, x's are the same here, and up here, x's are the same. When we multiply them together, we can add them together, add up the exponents to get our answer. Let's try to take a look at some simplification problems. So we're going to rewrite again. Here's our rules. I'll write them down here. B to the mth power times b to the nth power equals b to the m plus n. Same thing holds true for b to the mth power divided by b to the nth power equals b to the m minus n. Those are the two rules that we're going to kind of apply up in here, so keep these in mind. Again, the bases have to be the same. If the bases are the same, then we can add up m plus n to get an answer. If the bases are the same when we're dividing them, we can subtract m minus n over here when we're dividing these in kind of real life. So let's go up here and apply this up here. Let's go to the first question. W to the 3rd power times w to the 4th power. A little bit small. W to the 3rd power times w to the 4th power. Are the bases the same? If they are, then we can apply this rule down here, because the bases have to be the same. If the bases are the same, w is the same as w, then we can apply this rule down here and say that this should be the w. Again, the same base has to hold true here, and the answer, this would be w to the 3 plus 4 equals w to the 7th power, and that would be our answer. So could we leave it like that? It probably would not be beautiful math, so we'd probably want to rewrite it as w to the 7th power. Let's take a look at 2 cubed and 2 to the 4th power. And you know what? I'm going to leave that one for you, because we're going to come back to that one. Let's go to this one. I'll explain this one. Then I'll let you guys pause the video and see what you guys can do with the other ones. So let's go up here and take a look at y to the 15th power divided by y to the 8th power. That's a divided by sign right there between them. So are the bases the same? Y is the same as y. So we can go down here and say the bases. If the bases are the same and we're subtracting exponential powers, then we can say the base stays the same over here in the answer, and the answer, m minus n, is this numerator exponent divided by subtracted. Let me rephrase that. The answer is the base is the same as the base in the question, and m minus n is the exponent of denominator subtracted from exponent of the numerator. Kind of a long way around to say it's m minus n. So let's go back up here and see what we've got here. Our answer should be y, because why? Well, why? Because it's the same base. There's the same base here. It has to be the same base over here. And this should be the answer. 15 minus 8 is our long way around, but then the answer should be y to the 15 minus 8 is 7, and that should be our answer. So there's our answer. I'm going to let you guys pause the video and take a look at the videos, or sorry, the other examples that are here if you'd like, and we can just go through the answers. Alright, so this one here, 2 to the third power times 2 to the fourth power, are the bases the same? If the bases are the same, then we can add up the exponents when we're multiplying them together. So the base has to stay the same, and 3 plus 4 gives us 7. This one, 3 to the 15th power divided by 2 to the 8th power. Are the bases the same? 3 is not the same as 2, so really we can't do anything. These rules all depend on the fact that we have the same bases. Can we do anything with this? No, we really can't. So the answer should be 3 to the 15th power over 2 to the 8th power. And we could evaluate that. We could simply just evaluate it and say 3 to the 15th power is a number, divided by 2 to the 8th power is a number, and we can get a number out here. But we can't simplify based on these rules. Alright, let's take a look at a little complicated one. A to the third power times a to the 8th power would be a to the 3 plus 8 power in our numerator, and then in the denominator it would be a to the 7th power, and that then becomes a to the 3 plus 8 is a to the 11th power over a to the 7th power. That didn't change in the denominator. And now we've got a division problem here, because this is the base the same? A is the same as a, so we can go down here and say we can apply this rule, because as long as we've got the same bases we can subtract the exponents. So our base stays the same in the answer, and it would be a to the 11 minus 7 or a to the 4th power, and that would be our answer for that one. This one, by the same rules, you'd add up 3 plus 8 to get c to the 11th power over c. And let's go back here and say we have to assume it's not written here, as the exponent is not written, so we have to assume what it is. We have to assume that it's a 1. So we have to go over here and assume that it's a 1, because we can't say that it's c to the 0th power. We'll get to that in just a second. So this now is c to the 11th power, because 3 plus 8 gives us 11. C to the 1st power in the denominator is there. And now this is c to the 11 minus 1 is c to the 10th power, and that should be our answer. Whew, this one is kind of crazy. For these kind of questions, we have to multiply the numbers first, the coefficients. 4 times 3 should give us, I'm going to change pen color here too. This should be 4 times 3, because I'm going to rewrite just the numbers. I'm going to put the numbers out in front, and then I'm going to say this is going to be x squared times x to the 5th power, and we can just rewrite all these because we can. 4 and 3 can come out in front. X's can be grouped together. Y's can be grouped together as a base. This would be y to the 3rd power times y to the 7th power. And now we can just simply multiply things out. 4 times 3 is 12. Oops. Alright, let me go here. Sorry about that. We could take a look at the x's now and say x squared times x to the 5th is x to the 2 plus 5 is x to the 7th power. And we can say that we're looking at the y's, we can say now this is y to the times y to the 3 plus 7 power, y to the 10th power. And there's our answer. 12 times x to the 7th power, y to the 10th power. By the same token, we can kind of regroup and kind of pay attention down here to numbers and x's and y's. So just kind of take a look at each individual base and kind of separate and conquer, let's say. So let's take a look at 81 divided by 9 should give us 9. X to the 4th divided by x to the, again, 1st power. There's nothing written there, so we have to assume it's an x to the 1st power. So it's x to the 4th minus x to the 1st power gives us x to the 3rd power. And then y's are y to the 7th power divided by y to the 3rd power. We can apply the second rule down here, the property of division. Same bases, so we subtract the exponents. Y to the 7 minus 3 is y to the 4th power. And that should be our answer there. Alright, let me know how you did. Make sure you write down questions, and we'll talk about applications next time. But here are the answers. If you feel comfortable with these, that's great. If not, bring some questions, review the video, and we can talk later.